Okay, example 2 says find the fourth roots of negative 4. So again, we have a real number, um, but it says this time find the fourth roots of negative 4 in the form a plus bi. So I need to get my roots into this form, okay, whereas before um, I had them just as simple numbers. This time we'll probably have them as more complex numbers. Okay, and then for part B it says, hence, using our results from A, write z to the fourth plus 4 as a product of real quadratic factors. So please be mindful of the word hence here. Okay, hence means use the previous results to um, solve a problem or use it for the next question. Okay. All right. So let's look at part A here. Find the fourth roots of negative 4 in the form a plus bi. So that really means find z to the fourth power equal to negative 4. So we're going to do the exact same thing. Okay. We're going to get this into cis form. So we're going to use the nth roots method. We could use the what is it, factorization method, but let's just keep practicing the nth roots method because that one always works. So z to the fourth equals negative 4, so that would be z to the fourth equals, now this is minus 4, so that would be in polar form, that would be over here, and the angle then would be pi, and that would be a length of 4. So this would be a magnitude of 4 cis pi. Okay? Now, we change this into the more general form, so this becomes cis of pi plus 2 pi k, where k is a positive or just an integer, sorry. Okay, and then we use De Moivre's theorem. We take the fourth root of both sides, so we end up with z equals 4, sorry, I guess I'm not using De Moivre's theorem yet, 2 pi k raised to the 1 over 4 power. Now I use De Moivre's theorem and I get 4 to the 1/4, and I end up with cis here. This angle is multiplied by the exponent, so I get pi plus 2 pi k all over 4. And this simplifies to 2 to the 1/2 power, right? This is just root 2 cis of pi plus 2 pi k all over 4. Now, if I were to, now I can substitute values of this. So this is my general formula for the roots. Now I just plug in values of k. All right, when k is 0, I end up with z equals 2 to the power of 1/2 cis of 0. That would be pi over 4. When k is 1, we have 2 to the 1/2 cis of 3 pi over 4. When k is 3, or sorry, 0, 1, 2, so that would be 2. So that would be 2 to the 1/2 cis of 5 pi over 4. And 2 to the 1/2 cis when k is 3, 7 pi over 4. Okay, so notice I have 1, 2, 3, 4 answers, and that makes sense because I need to have 4 answers there. So going back to the units, or going back to what these are in a plus bi form, let's figure out what those are. Cis of pi over 4 would look like that. This magnitude would be root 2. And since that angle is pi over 4, that's nice, that's just 1, 1. So we end up with z equals 1 plus I. What about this one? That would be over here. Magnitude stays the same, right? And this would be just minus 1, 1. So we'd have minus 1 plus I. This one would be down here, okay? And the last one would be there. We would have a nice circle there, uniform circle. Well, yeah. And this would be minus 1, so it would be minus 1 minus I, and 1 minus I. So those are my four, these are my 4 numbers, my 4 solutions, where if I take these, raise them to the power of 4, I would get negative 4. Okay? Now for part B it says, use what you know about A, hence, right? Write z to the 4th power plus 4 as a product of real quadratic factors. So that's saying, let's get z to the 4th plus 4 to be the the product of two factors, where these are quadratic in nature. It'd be something like this. We'd have z squareds in here. Okay? So, this, we have to go back. I mean, I guess you could, write these as z plus or z minus each of these and just multiply those two together. But you could also use your knowledge of sums and products of roots. And if you want to go back, you can look back at chapter 1c, going all the way back to quadratics, okay? And using quadratics of sum and product of roots, we can say z to the fourth plus 4 will be two real quadratic factors that can be found using conjugation. Okay, so let's look at 1 plus or minus I. What are the sums of those roots? The sum of these roots would turn out to be, if I added 1 plus I plus 1 minus I, that would be just 2, right? The sum is 2. What about the product of these two? If I multiplied this times this, if I had 1 plus I times 1 minus I, that would be 1 squared. These would cancel out, minus I squared, which would be positive 2. Okay? If I did minus 1 plus or minus I, the sum would be negative 2. Okay? And the product would be positive 2. Okay? And so once I have these two, now I can write these as a quadratic. I can use the sum and the product, these two numbers, as a quadratic. So this, so for this one we would have z squared, okay, minus the sum, which would be 2z, plus the product, which would be 2. Okay, so this would be the quadratic that has these roots. And the quadratic that has these roots would be z squared minus a negative 2 times z, plus the product, which would be 2. And so z squared, z to the fourth plus 4 would be, okay, z to the fourth plus 4 would be this product times this product. So it would be z squared minus 2z plus 2 times this quadratic, which would be z squared plus 2z plus 2. Okay, so there's my answer.